just going to review the things we've done so far. All right, so the first thing is I'm just going to make up any standard quadratic that we can factorise. So let's just take a couple of nice easy numbers, a bit like that. In fact, I don't want an odd number there because we're going to later on, we're going to complete the square. So two numbers, we're going to factorise this to begin with. Two numbers which add together to make 8, but multiply together to make 15. So I've made it nice and easy, there's no negatives, do practice the harder ones. So when you factorise something that looks like that, this case, no particular order, 5 times 3 makes 15, 5 plus 3 makes 8. We've factorised it. Then the next skill was solving, where we put it equal to 0. Normally it's y equals, but it's equal to 0 due to the fact that you're going to look for coordinates called solutions, which are basically coordinates, x values along the x-axis. So you set y equals 0 because that is the alternate name for the x-axis. And as we know, the quick way was just to change the signs. So -5 and -3 would give us the two solutions. Now the bit we haven't mentioned is how that affects the graph, is how we look at the graph, but we'll look at that in a sec. I'm going to alternatively, we'll come back to completing the square, let's just look at the quadratic formula. So a reminder, in the quadratic formula, the letter A stands for the coefficient, the number next to x. So in this case, a nice easy 1. B stands for the number, the coefficient of x, which in this case is 8. And C, the constant, is simply the number on the end. Again, I've picked these so they're easy. So it's a nice example. As we mentioned before, take extra care with negatives, particularly when you're doing the -4ac part. So I will write down the quadratic formula just as a reminder, but I'll do it the cheating way. And I'll rub bits out. So you in an exam, you'd set up another line. Me cheating here, I'm just going to rub things out. So one thing at a time, -b means -8. Just straightforward substitution and then followed by big mass. So b squared, again, if it's a negative, take care. In this case, it will always be positive. That's the key, no matter whether b is plus or a minus. Then, and this is where you did it as a separate piece of working out, which totally makes sense, particularly when the numbers are harder. Here, they're not so hard. So -4 times 1 is -4. -4 times 15 is -60. So again, help yourself as you go along, do one step at a time. We'll simplify that shortly. We'll just make sure of this. 2 times A, 2 times 1 is 2. So you've earned a mark for correct substitution, and in some cases they even allow one mistake and you still get a mark. So applying the laws of big mass, brackets and indices come first. You always work on what's called the discriminant, is the posh word, just in case you see it in revision texts. We just work this bit out. 64 take away 60. Again, if the numbers are hard, reach for the calculator. If they're not, work it out as simply as you can. Square root of 4, again, I've made this nice. Square root of 4 is 2. Like so. And this is where we reached for the calculator last week. One thing at a time. I always do the plus bit first. So -8. Go up 2, takes me to -6. -6 divided by 2 is -3. let's go for the minus part. Negative 8 take away 2 means I go down to minus 10. Minus 10 halved is negative 5. So it is no coincidence that these answers are the same. Absolutely no coincidence. Our two solutions, in no particular order, are negative 5 and negative 3. So in an exam, which one do you use? You always go for this first. You see if it factorises. But if there are any clues, like give your answer to 2 decimal places, no chance. You've got to go reaching for that. If there's no clues whatsoever, stick to factorising. Don't forget, the one thing I'm not going to mention now is when there is a number next to x squared, when there is a coefficient, that's when you do the AC method. That's the bit I'm not going to overcomplicate with now. But the AC method, what does that change? It makes this a little bit harder. It doesn't really make the quadratic formula any harder. So that's where, if it doesn't matter which way you do it, this is where you can start leaning to the quadratic formula being the most efficient way. Depends on whether you like the AC method or not. So let's now connect the dots between these two which work the same, and let's just see what will happen on a graph sketch. What do those two things tell us? Well, quick reminder, anything with a positive x squared is a U-shaped graph. A negative x squared would be a peak-shaped graph. So we know we're dealing with that. And what do these tell us? They tell us that the U part of the graph crosses at negative 5 and negative 3. And that's your sketch. That's what they tell us. Solutions are where the graph crosses the x-axis. Next thing that you need to be careful of, because examiners do want you to do what's called label all key parts, them two being 2 of them. The third one is labelling that there. And again, it is no coincidence that that number there in the y equals mx plus c, the equation of a straight line, the c is the intercept. The c is where the graph cuts the y-axis. So again, it all fits together there. Now you don't have to worry about it being to scale. It'll be called a sketch. You can put the markings on. Only when it's on squared paper. And that tends to be more of a substitution question again. That's for another time. So when it comes to factorising or formula, those two methods find solutions. What does completing the square find? Well, let's complete the square first. So don't forget the technique, always the same. To complete the square, you halve the number next to x. All right, it's always squared, and it's always squared and taken away. That's your first step in completing the square. I have not yet done anything with the plus 15, so that remains. And the final stage, before we start solving it, is simplify. Negative 16 plus 15 is negative 1. We have now successfully completed the square, or in other words, we have written it in the complete of the square form. Now, completing the square is the worst technique for solving, but they can sometimes ask you to do it that way. So let's just solve it. I'm ultimately going to rub it out. So don't forget how to solve it. You bring in the equal to 0, and the method I explained to you was do opposites work right to left. So opposite of -1 is add 1. Opposite of squaring is square root. What is the square root of 1? 1. But don't forget there's always 2 square roots. So the square roots of 1 are plus and minus 1. So got rid of that, got rid of that. Do the opposite of that. I take 4 away from both sides. And it is no coincidence that -4 plus 1 is -3. -4 take away 1 is -5. That's where they all fit together algebraically. But as I've mentioned before, solving using completing the square is the least efficient way. When you start getting into the higher grades, talking grade 7-ish, the A grade stuff now, they will start asking you questions along the lines of state the coordinates of the vertex. So this is a new bit that we've not yet mentioned. They always use capital V for vertex. Or they will ask you to state the equation of the line of symmetry of the graph. So we're going beyond the stuff we've done before. So all quadratic graphs are symmetrical, and there are 2 techniques available for answering where is the vertex. That's the lowest part of the graph. If it's one of them, it will be the maximum part of the graph. And the line of symmetry. Don't forget, that's the y-axis. Another name for the y-axis is x equals 0. So any line which is vertical has the equation x equals. So how do I find its line of symmetry? Well, if you know the coordinates, the graph can only be symmetrical. The line of symmetry must be halfway between them. So halfway between -3 and -5 is -4. You have correctly got the halfway point. That's a tick for the line of symmetry. What happens if you're asked for the vertex? Well, you already know the x value. All right, what you don't know is the y coordinate, because it's 4 to the left. Yeah, fine with that. It's how far down. That's why you complete the square. It is no coincidence that this -4 is opposite to that. That will always be the case. And it is no coincidence that the number on the end happens to be the y coordinate of the vertex. So that's how they all fit together. So a very quick reminder, when you are factorising, that finds solutions. When you are using the formula, that finds solutions. When you are completing the square, that can find solutions, but it is definitely the least efficient and potentially the most tricky. So completing the square is usually done if they ask you for a line of symmetry or the vertex. So if an exam question simply says to you, here's a quadratic, find the coordinates of the line of symmetry, find the coordinates of the vertex or the equation of the line of symmetry, that's one thing that you need to go, I'll complete the square is the most efficient way. But if you really, when you get to the exam in June or May, June-ish, when you get to the maths exam, you can avoid doing completing the square if you hate it, because you simply do one of the others and go halfway between. The downside being, it could be in surd form, as in it goes to decimals, which rarely means the factorising is eliminated and you have to go for quadratic formula as opposed to factorising. So it's a case of, best thing to do for revision is revise the 3 techniques on their own. Make sure you've got all 3, but also on the go, do quadratic graph work. And when it comes round to the summer, 2 of these skills will be on the paper as a minimum. A bit like we've talked about with trigonometry. All right, will Pythagoras or SOHCAHTOA come up? Don't know, but one will, minimum. And maybe the next level will crop up as well. So big marks for these, not easy, but well worth putting the time and effort in due to the fact there's a fair whack of marks available.